Okay, so today we're going to be doing derivatives of polar functions, and for illustration and explanation we're going to use this question here. For what values of theta are the tangents of the polar function r equals 2 minus 3 cos theta horizontal? Okay, so first of all, I'll tell you what, let's have a look what the graph looks like by doing a little, so that's theta and that's r, so let's have theta going 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4 and 2 pi. Okay, so when theta equals 0, we have to stick theta equals 0 into here. Then cos of 0 is 1, so that means r is minus 1. Okay, so let's put that point in. Well, theta, we know that theta goes around, if we have a look, theta goes around here from 0 to 2 pi, that's theta. And r is the distance away from the origin. So basically, if we have a negative r at theta equals 0, well, theta equals 0 is here, and negative r means it's in the other direction, which means it's in the 0 plus pi, which is 0 plus 180 in the other direction, which is here, which is that point there. So that's the point 0 minus 1. Okay, now when it's pi over 4, sticking that in, we get 2 minus, let's have a look, 2 minus 3 over root 2, and 2 minus 3 over root 2 is again slightly less than 0. So when theta is pi over 4, we would have the point around here because it's negative, so it's in the opposite direction. Okay, now when theta is pi over 2, cos of pi over 2 is 0, so we know it's 2 there, so that's quite easy. So we know now that it's gone up to this point 2, so we can draw this now something along the lines of that. Okay, this is bound to be an awful drawing, and my apologies. Okay, so 3 pi over 4, well, cos of 3 pi over 4 is going to be minus 1 over root 2, so this would be 2 plus 3 over root 2, and then at pi it's going to be 5, because cos of pi is minus 1, so that'd be 5, so that'd be this point about here. So then it goes around here like this, and then basically we just have the symmetrical bit of it. So this is here 2 plus 3 over root 2, 2 minus 3 over root 2 and minus 1, and that's going to make the rest of it look like, and this is going to be awful, so I apologise in advance, it's going to make the rest of it look something along the lines of that. Okay, and the point where it goes through the origin, by the way, is basically where cos theta equals 2/3, because when cos theta equals 2/3, then that is equal to 0. So r, which is the distance from the origin, equals 0. And cos theta equals 2/3 when theta is approximately 0.84 radians, which is just slightly more than pi over 4. So basically, then when theta is about here, somewhere about here, it will be 0. And also when theta is somewhere around here, then it will also be 0. Now, fortunately, we have desmos.com, and I knew I wouldn't draw it very well. So desmos.com here this is the proper version. My version is not that bad, but desmos.com was obviously a lot better, so thank you to them. Okay, so the question asks us when we need to find out when the tangent is horizontal. Well, clearly the tangent is horizontal here, and 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 we need to find the theta values. Well, the theta value basically for this point here is when theta, so we have the theta here, and this point here, we have the theta here. And then for this point here, we have theta here. And for this point here, we have theta here. And remember, these 2 points here, this will be theta measured, it's measured around, isn't it? It's measured around from 0 to 2 pi. So this one will be theta going from there to there. And the other one will be theta from there to there. And the two smaller ones, remember, will actually be the theta which is in this direction here, because the r is negative, but we're going to find those out. Okay, so we need to find those 4 thetas where which are between 0 and 2 pi. So let's get on with the calculation. Okay, so we know that r equals 2 minus 3 cos theta. That's from the question, and we know obviously that the parameterization of this is that x is r cos theta and y is r sine theta. Anyone who isn't aware of that, basically if we just have our xy curve here and we draw any old point here, xy, then that distance there is r, which is by Pythagoras, the square root of x squared plus y squared, and that is theta. So the point xy, the x coordinate is r sine theta, or cos theta, and the y coordinate is r sine theta. That's where that comes from. Okay, so what we need to do is we need to work out when dy dx equals 0 to get these 4 horizontal points. Okay, so what we need to do, let's have a look. So we've got x equals r cos theta, so therefore dx d theta dividing by, finding the derivative with respect to theta is equal to, now we have to use the product rule because r is a function of theta, so basically that is dr d theta times cos theta minus r sine theta, just use the product rule on that, and then y is equal to r sine theta, so therefore dy d theta is equal to, again by the product rule, dr d theta sine theta add r cos theta, and therefore dividing one by the other, dy dx is equal to dr d theta sine theta add r cos theta over dr d theta cos theta minus r sine theta, and we want to find out when dy dx is 0, i.e. when the tangent is horizontal, so all we need to do is find out when this bit here is equal to 0. Okay, now we know that from up here, r equals 2 minus 3 cos theta, so let's just work out dr d theta equals, dr d theta is basically 3 sine theta, and we can plug that into here. So now all we need to do is we need to find when 3 sine theta, just plugging into here, add r cos theta equals 0, and we know that r is equal to 2 minus 3 cos theta, so that means we got 3 sine squared theta add brackets 2 minus 3 cos theta equals 0, and now we have our equation in only theta, and all we need to do is solve this. So that's 3 sine squared theta add 2 cos theta minus 3 cos squared theta, okay, equals 0. And putting that as 3, 1 minus cos squared theta, add 2 cos theta minus 3 cos squared theta equals 0, i.e. 3 minus 3 cos squared theta, add 2 cos theta minus 3 cos squared theta equals 0, and so we end up having 6 cos squared theta minus 2 cos theta minus 3 equals 0, and that is a quadratic equation in theta, or in cos theta, that we can solve easily. So we have, using the quadratic formula, cos theta equals minus b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times a times minus 3 all over 2a, which equals 1 plus or minus root 19 over 6. And that is our answer, but we just need to tidy that up slightly a little bit here. Let's just go on to the next page here. So basically we have our 4 solutions, and if we look back at our diagram here, we have 4 solutions for theta. It's not very clear, that one, that one, that one, and that one. So we do need 4 values of theta, but we have all the 4 values here. So we have, let's say, a cos theta equals 1 add root 19 over 6. Well, that gives us that theta is approximately 0.47 radians, or theta is approximately 2 pi minus 0.47 radians, which is basically, if we look at our all stations to crew here, we'd have here, which is 0.47 radians, or 2 pi minus 0.47 radians, which is the one going all the way around there, okay, which is approximately 5.82 radians. So there is our first 2 answers, theta approximately 0.47 radians, or theta approximately 5.82 radians. And the second answer we get, which is cos theta equals 1 minus root 19 over 6. Well, that gives us theta is approximately 2.16 radians, and theta is approximately 2 pi minus 2.16 radians, which is 4.12 radians, which again is basically theta being approximately this point here, which is 2.16, and its mirror in the x-axis here, which is 4.12 radians. And you can see that this one here and this one here correspond to, it's a little bit messy there, but it basically corresponds to this point and this point, where, remember, the angle is here, but the r was negative, which is why it's over in that direction, and the angle was here, but the r is negative, why it's over in that direction. And then here, I know I've drawn it pretty badly, but then here, which is where the tangent is 0, and here, which is where the tangent is 0 as well. And so they are basically the 4 angles of theta. Okay, well, I hope you've found this useful and found some of my drawings a little bit hilarious. But if you have, please press the thumbs up button and subscribe to the Gressy Academy YouTube channel. Thank you.